A rectangular concrete beam of 30 cm depth, that is 300 mm deep and 200 mm wide, is pre-stressed by means of 15 5 mm diameter tenons or wires located at a distance of 6.5 centimeters from the bottom, that is 65 mm from bottom, and 3 bars of 5 mm dia located at 2.5 centimeters from top, that is 25 mm from top, assuming the pre-stress in the steel as 840 kN per mm square. So pre-stressing force will be equal to stress into area, that is equal to 840 Newton per mm square into area of wires is 15 bars of 5 mm dia, so 15 into pi by 4 into 5 square, plus 3 bars of 5 mm dia, so 3 into pi by 4 into 5 square mm square. The pre-stressing force in kilonewton will be obtained as 296.88 kilonewton. Given density of concrete as 24 kilonewton per meter cube, then dead load will be equal to 24 into zero point 0.2 into 0 0.3, which is 1.44 kilonewton per meter. Live load is given as 6 kilonewton per meter and span is given as 6 meters. Then first let us find centroid of the wires. Centroid of wires, say from bottom as y bar, which will be equal to bottom there are 15 bars of 5 mm dia, so 15 into pi by 4 into 5 square into at a distance of 65 mm from bottom, plus top there are 3 bars, area is 3 into pi by 4 into 5 square into their distance from bottom will be 300 total depth minus distance from top by 15 into pi by 4 into 5 square plus 3 into pi by 4 into 5 square. So the centroid will be obtained as 100 mm. Total depth is 300. Then from CG it will be 150 mm. Centroid is at 100 mm from bottom, that is from top. Eccentricity will be, let us separately draw it again. Rectangle, depth is total 300 mm, so up to neutral axis it will be 150 mm. So the resultant cable will act here 100 mm from bottom, that is 50 mm from neutral axis. So our eccentricity now is 50 mm. Let us calculate moment due to dead load first. Dead load is 1.44 kilonewton per meter into L is 6 meters, so 6 square by 8, which will be equal to 6.48 kilonewton meter. Whereas moment due to dead load plus live load will be equal to 1.44 is the dead load plus live load is 6, so into 6 square by 8, which is equal to 33.48 kilonewton meter. So the stresses first due to dead load alone at bottom will be P by A plus PE by Z minus M by Z. Substituting, P is 296.88 kilonewton, so into 10 power 3 in newtons, by area is 200 mm by 300 mm, so 200 into 300 plus again P is 296.88 into 10 power 3 in newton, E is 50 mm, so into 50 by Z is BD square by 6, so 200 into D is 300 square by 6 minus moment due to dead load is 6.48 kilonewton meter in Newton mm into 10 power 6 by Z is 200 into 300 square by 6. Individually the values are 4.948 plus 4.948 minus 2.16. The value is 7.736 Newton per mm square. Whereas at the top it will be P by A minus PE by Z plus M by Z, that is equal to 4.948 minus 4.948 plus 2.16. So this will be 2.16 Newton per mm square. Whereas other cases when dead load and live load are acting, in that case moment is 33.48 kilonewton meter. So stress at bottom will be due to pre-stressing force P by A plus PE by Z due to eccentricity minus M by Z, M where M is here due to dead load plus live load. Substituting this value we already got as 4.948. This is also 4.948 minus this is 33.48 into 10 power 6 in Newton mm by B is 200 into D is 300. So 200 into 300 square by 6. So this value will be 4.948 plus 4.948. Individually this value is 1.264. So the resultant will be minus 1.264 Newton per mm square. Whereas at top it will be P by A minus PE by Z plus M by Z. So that is equal to 4.948 minus 4.948 plus this value is 11. This individual value is 11.16. Resultant value is 1.264. So this is 11.16. So individual value is 11.16. This gets cancelled. It is 11.16 Newton per mm square. Since it is negative, it will be in tension. It is positive, it is in compression. The resultant stress at top it is positive 11.16, at bottom it is negative, having a magnitude of negative 1.264, here positive 11.16. So the maximum working stress in concrete is 11.16 Newton per mm square.